This is popular as well. Determine the what? I've asked this question a lot. Equation of the what? Line tangent to the curve. Tangent to what curve? Y equals e to the x over x at the point, okay, you always have to have a point on the curve at this location, okay? Do you guys remember these kind of questions? Hopefully. Let me see if I can do this. What can I do? Huh. I guess what? Artificial intelligence isn't really working. Should hit cancel. Anyway. How do you guys find that? Do you guys remember from Calculus 1? What is that? I want you to find what? Equation of the what? Equation of the line. Well, algebra, what is this? Algebraically speaking. Close. Y equals y1 minus m x minus x1. That's the equation of the line formula. Okay? Now you need a point. Okay? And sure enough, what do? They give you a what? Point. Here's the x coordinate. Here's the y coordinate. In fact, this is the one and only point. So in other words, x1 is 1 and y1 is what? E. Okay? I'm going to color it, orange. Here, there we go, and then green. Here, there you go. Okay, so what I'm saying is, so far it's y minus e is m x minus 1. That's the equation of the line. That's from beginning algebra. I do this all the time in Calculus 1. Hopefully people are sick of it, right, Blanca? Sick of it, right? You say, why am I sick of it? Because I've seen it over and over again. A lot of those things. And then, what do they mean by tangent to the curve? This portion, right? Tangent to the curve. What is that? This is code for what? Right in here. What do you... M, see this portion? This is really M what? M tangent. So you should have seen these questions over and over in Calculus 1, M tangent. How do you get the M tangent? Do you guys remember? How do you get that? That's the derivative evaluated at x equals what? x1. In this case, it's 1. So you need the derivative of the what? Of that function, ladies and gentlemen. So could you take the derivative here of that function? We can. Remember this. M tangent is the derivative of e to the x over x. How do we get that derivative? What's it called? Quotient what? Rule. Quotient rule. So I know what this derivative here is. E to the x is e to the x. I know the derivative of x is 1. Is that right? So they're saying that m tangent is x e to the x minus e to the x over x squared. And moreover, you evaluate that from x equals what number again? What's the x1 value? It's right in here. x1 is what? 1. It's the x coordinate from the one and only point. So that'll be 1. So you say, oh, I just have to plug in a 1 here? Yes. 1 times e to the 1 minus e to the 1 over 1 squared. So what's m tangent? Is that 0? What does that mean? Huh. If the slope of the line tangent to the curve is 0, what does that mean? Do you guys know what that means? Here's the meaning. Yeah. It's horizontal where? It's horizontal at the location 1 comma e. You go, horizontal? Yeah. So if that slope is 0, and sometimes that happens, you go, I replace this with a 0? Yeah. Okay. So that means 1 minus e is 0 times x minus 1, or 1 minus e is 0, or y is just e? Yes. This here is the equation of the line tangent to the curve at the point 1e. Doesn't always happen. Sometimes you get the slope being a number. But I'm going to want to take a look at that. Where's our Desmos? You guys remember Desmos? Where are you, Desmos? Here you go. Y equals e to the x, come out of there, divided by x. And you guys know I don't like using red for my curves. Okay? So at 1, where do you think that's at? You guys see where 1 is here? See this curve? This is the curve. Y is, this is the curve. Y equals e to the x over x. That's the curve. So when x is 1 right in here. That other number will really get close. That other number, by the way, is e, 2.718 approximately, right? So sure enough, isn't that horizontal? Is there a horizontal tangent line at that? You might say, what is it? Well, y equals e. That one I'll make red. Okay, so at the point, there's that horizontal tangent line, y is e, at the location 1e. So yes, you have a horizontal tangent. It's also a location of a relative what? Min. If you're setting at 1, is that a location of a relative min, by the way? What do you guys think? It should be. All right. All right, just to kind of remind you guys, and then just to kind of clear on out the Calculus 1 cobwebs, right? And then, do you guys happen to know, how about this? Same question. X, e to the y, y, e to the x is 1. Determine, again, equation of the what? Equation of the line. Tangent to the curve. Here we go. At what location? 0, 1. It's the same question. Okay? They gave you again the one and only point here, right? So in my mind, they go, oh, equation of the line. Oh, okay. Algebra. Y minus y1 is m x minus x1. This is the one and only point. So y minus 1 is m x minus 0, or y minus 1 is mx. What do you really need, ladies and gentlemen? You guys know what you need? The slope. That's m what? That's really m tangent. Because I want the equation of the line tangent to the curve. M tangent. But anybody notice what they gave you? What is this? guys know what this is, by the way? This is a relation. So if you have to find y prime for a relation, what am I thinking? Anybody know what I'm thinking? I got to find that derivative. That's my m tangent. Go back to calculus 1. What am I thinking? How do you get y prime for a relation? Anybody? What's it called? What do? You do what? There's a name of the process. What's the name of that process? Implicit what? Differentiation. Yes. And what do you always assume? Y has to be a function of x. Y is not a constant. So when you do an implicit differentiation, you differentiate. Remember that process? Differentiate the left side and the what? And the right side. So implicit differentiation is also in calculus 2 because it was in calculus what? 1. You guys okay with that one? And then now you say, okay, what do I do? Well, what you do here is this. Derivative of a sum is sum of what? And the derivative of 1 is 0, by the way. So I'm going to differentiate that. Now, remember what I'm saying here. What rule do you use for both of these? Right? You're going to have to use what for both of these? What is it called? Product rule. Product rule. Is that true? So let's use product rule. X d dx of e to the y plus e to the y dx of x. Now, this is going to be, I'm going to do this here. I'm going to color it this. This is going to be my first product rule. So all of this is that first product rule. But you have another what? Product rule. So this is y d dx e to the what? X. Okay? Plus e to the x dy dx. And then that will equal 0. So here's the second product rule. So we're going to have to do some derivatives, and some of these things are easy, right? Here's what I mean. What's this derivative? What's the derivative of x? 1. What's the derivative of e to the x? And then this is dy dx. You guys know what that is? That's just what? That's y prime. But probably for people, they're going to forget this. What do you use here to differentiate? Right? Remember I said implicit differentiation. This y, there's the same y, by the way. They're functions of what? X. Y is a function of x. Y is not constant, bless you. Don't say y is constant. Y is a function of x. So what does that mean I have to use here to differentiate? Okay, you guys know what it is? What do I say? Chain rule, yeah. So that's going to be e to the y times dy dx. Okay, so all together, let's write this down here. We have x e to the y dy dx, okay, plus e to the y, plus y e to the x, okay, everything together here. And you say, is that going to be plus e to the x y prime? I'll say yes. I'm going to recommend you change this dy dx to what? Y prime. Okay, so remember that the last step is always solve for what? Solve for y prime. Double check, see if we didn't mess it up. All right, double check the work, ladies and gentlemen. X e to the y prime, yeah. plus e to the y plus y e to the x plus e to the x y prime. Okay, remember we have to solve for y prime, but in the context of the question, they want y prime evaluated where? At the location here for these x and y values. X is 0, y is 1. So what I would do personally, I go, oh, wherever there's an x, here, replace it with what? 0. Wherever there's a y, if I can change this color, replace that y with what? 1. 1. So here's what you end up with, okay? You get like 0, e to the 1, y prime plus e to the 1 plus 1, e to the 0 plus e to the 0, y prime equals 0. Is that true? And I ran out of space. Double check. I'm not leaving something out, right? So, I don't know. What does that give you? What do you think? Isn't this e? E plus what? Plus 1 plus y prime is 0. Is that what it is? I think so. Is that true? So what does that mean for y prime? What does y prime equal? Y prime is negative e minus 1. And more than that, that's m tangent evaluated at the location 0, 1. Okay? This is what you're looking for. It's the derivative, if you guys remember, at that location. So that's minus e minus 1. So what do you do now? What do you do with this? This is minus e minus 1. Okay, so y minus 1 is negative e minus 1x, almost done. Add 1 to both sides. What do you guys end up with? Y is negative e minus 1x plus 1. This is that thing called what? Tangent. Equation of the line, tangent to the curve at the location here. Okay, because you have really a relation. That curve is a relation. How do you know it's a relation? How do you guys know that this is really a relation? Oh, that's not it. Where are you, Desmos? Okay. X. E to the what? Y. Come out of there. Plus y. E to the what? X. That equals what? 1. And I don't know if you can see it. Maybe it's just too... It might be too much for Desmos. It might be actually a little bit too much for Desmos, ladies and gentlemen. Did we screw that up in any way? I don't think so. X e to the y plus y e to the x equals 1. Come on, Desmos. See, this is why you can't trust technology or artificial intelligence. Okay, it might be a little bit too complicated for even Desmos. I gotta see. Anyway, that was a point I wanted to make, but I can't make it. Sorry. Sorry, Desmos. We outwitted you. But you guys remember this process, hopefully? Finding out tangent. But this time they gave you a relation. And how do you really know you have a relation? Just so you guys know. Graphically speaking. What's a relation? There's a test graphically. That's what I tried to show you guys. Hopefully the graph came out, but it didn't. But how do you know you have a relation? Vertical line test. It'll hit your curve in how many spots? More than one. Think of a circle. X squared plus y squared is 1, right? Hits the curve in what? 2 spots. It's a relation. It's not a function. So those ideas are back in what? In Calculus 2. And so I think, hopefully, ladies and gentlemen, there's enough lecture and background to get started on what do you guys have for assignment for homework 1? Do you guys see to kind of get started on that? Do you guys know? Come on. Do we give you some integrals of trig functions? Do you guys have some of those integrals? Okay, so hopefully you guys could do some of those. You got some derivatives? Try to do some of those. Oh, shoot. And then we're going to start, we might even be on 7.2. Double check. We might be on 7.2, some of these questions. So tomorrow we're going to start talking about what? Logarithmic functions and their limits and derivatives and integrals and so on. So we get to repeat the process, but now with what? Logs. So take a look, ladies and gentlemen. I hope you guys enjoyed the lecture. I hope you guys cleared some cobwebs, but some of that stuff is back. Is that right? All right, we'll see you guys tomorrow.